Namaste. This is the assignment 1.5a of Verilog under the Agimus Technology Internship in the Xilinx Spartan 6 platform. So here we are going to build the full adder using the basic gates. So for that, in this IC tool, I already write this small Verilog program. Full adder means we need to have the three inputs A, B and the carry in, and sum and the carry out. These two are its output. Okay. Then here for making the output, the sum is the output. Sum equals to A XOR B XOR C for a full adder. Here we can see where is that? Here we can see the truth table of the full adder. When we give the 0 0 0 carry in, it will going to make the addition of that, and it will going to give us the output of sum and the carry out. So here for example we have 1 1 1 1 1 1 means the value is 3, that is 1 1, so sum is 3 and the carry is 1. Like that it will going to give us the output, the full adder. So first of all, what we have to do means we just do the XOR A B C and assign that to the this sum. Okay, so the sum becomes A XOR B XOR C. Then in order to get the carry, it is AB plus BC plus CA. So for that we are just using the wires because we need to store this temporary things. So AB, that will going to store, I'm using T1, T2 and T3 as the wires. So AND operation, here we are doing the AND operation, A and B plus B and C plus C and A. Like that we are going to do. So first I did the AND operation of AB and then BC and C, and then I stored that in T1, T2, T3. Then I just did the OR of T1, T2, T3, and that is assigned to this carry. So the carry becomes AB plus BC plus CA. So now we are going to just check this, and that means generating the program file, and we are uploading. Do you want save? Okay, and pin configuration, we can see that here this for the input ABC, that I'm using the those switches, that means these switches I'm going to use DIP switches, and for output I'm going to just use sum and the carry. Okay, these two LEDs I'm using here. Okay, sum and the carry, this for the carry. And now we see it is generating. Let's wait for some time. It's successfully generated. Now we just need to add these programs. So manage now boundary scan, and we just need to connect this. Here we can display that it is displaying bit file, and here I just need to add the full adder. Okay, full adder dot bit. Then okay, we program our FPGA. Here we can see that it is connected, and we are just going to program it. Okay, I think you can see now properly. Now I'm going to just program this. It gets programmed. Now we will see the output by comparing with this table, that is the full adder table. So what I do means I just make this up screen, and now I think it's visible now properly. So in this DIP switches, first one we just need to get 0 0 0. I'm getting this as a 0, and 0 0 1 we have to do. Wait. Sometime what happens means it will not give us the output. So for that, what we have to do means if we have the like this here DIP switches, what I did means I just changed that to here we have those push buttons. I just commented this. I just commented this, and I just run this program and I uploaded. Then it works fine. Then I again changed back to this one, that means the DIP switches. Now it's working fine. We can see I'm just going to generate the program file, and I'm going to uploading. It will going to work fine. if sometimes that's occurred due to some technical problem, I think. Yeah, it will going to generate those files. Yeah, it is generating the programming file, and yeah, I'm going to complete. Okay, it's complete. Now I'm going to upload that to the board. So yeah, here we yeah, just resetted the board. Chillaz chain. Here we can see that. Okay, wait for 1 second. Yeah, this one no, and here okay, and yeah, I didn't upload it. I forgot to upload that file. So okay, we'll just close this, because here that file is not showing, it seems. This is the full adder.bit. Yeah, now this no, and I just need to upload this. So okay, here we will see. Yeah, it's just programmed. Now we can see this is, I'm going to just make this as a 1. This is my LSB, this is MSB. Okay, this port is MSB and this LSB. So when we compare this with this table, so here we can see yeah, 0 0 0, that is 0 0, that we observed. 0 0 1, that is this the sum, and this the carry out. Okay, L2. So now this is 0. So now if I make yeah, this is now 0 1 1, that we can see here. 0 1 1, that is the sum is 0 and carry we are getting as 1, and I'm just going to make 1 1 1. Okay, so now we need to get yeah, both two, sum and the carry are equals to 1 1. Okay, if I make just yeah, for example 1 0 0. Okay, now the sum only have to glow. Yeah, the sum is only glowing. I think you've understand about this. Thank you.